Hey guys, welcome to the Pre-Algebra 1.1 video. We're talking all about expressions and variables in this video. Alright, so the first item we'll discuss is a numerical expression. Okay, so what is a numerical expression? Well, it simply just consists of numbers and operations. Okay, numerical number, right? Okay, so 4 times 7. That looks like a terrible 7. 4 times 7, right? That is a numerical expression. You could have 4 parentheses 7, right? When you have a number right next to a parentheses, that means multiply, so this would also be a numerical expression. 5 minus negative 11 would also be a numerical expression. All right, so a variable, you guys know what that is, okay? It's just a letter. A lot of times we use X, but we can use any letter that's used to represent a number, and sometimes a variable actually represents more than one number when we start talking about inequalities. And then here, a variable expression, well, you think, well, if a numerical expression contains numbers, that a variable expression must contain variables, and you would be right. Okay, so a variable expression contains variables and operations, okay, but it also contains numbers. So a variable expression has both. A numerical expression only has numbers but no variables, okay? Such as x minus 7, okay? That would be a variable expression. We have an operation, okay, subtraction, we have a variable, there's a number. You could have 2x over y, okay? That would be a variable expression as well because the fraction bar indicates division. We have some variables and there's a number there. You could also have m over t. Right? That is also a variable expression. Even though there aren't any numbers, a variable expression doesn't always have to have numbers, but it will some of the time. Alright, so what can we do with expressions? Well, we can do a couple things. We can evaluate them. We can simplify them. But there's one thing we can't do, and that is solve. You cannot solve an expression. Okay? And why am I being, particular about that? Well, because we're going to learn to solve when it comes to equations, okay? And if we're thinking we can solve something we actually can't, we're probably going to end up with the wrong answer. So if you see something like 4 times 10, right? You can't actually solve this. You can evaluate it, or you could say you could simplify it, and that of course would be 40, but you can't solve. Solving is for equations only. What's an equation? Well, it's just an expression. It's two expressions that are split in half or separated by an equal sign. So 3x is an expression, 12 is an expression, and 3x equals 12. Now that's an equation which you could solve, but this is just an expression. You can't solve it. Alright, so let's work on evaluating. Okay, let's evaluate some expressions when x is equaling 5 and y is equaling 6. What do I mean by that? Well, if I gave you this expression, how would you evaluate that? Well, I hope you'd say, oh, you know what? I'm going to, when x equals 5. So whenever I see an x, I'm going to plug in a 5. So let's take that 5, plug them in there. And of course, 2x means 2 times x. So now we're really taking 2 times 5. And of course, that would equal 10. So why don't you pause the video, and I want you to try these next couple. Play the video when you're done with all of them and see how you did. Alright, there you go. So use x equals 5 and y equals 6 on these three. Play the video when you're done, see how you do. Alright, so number 6, you need to plug in a 6 wherever you see a y. So it's really like saying 3 times 6, which of course equals 18. Number 7, 4xy really means 4 times x times y. But in our case, x really represents 5 and y represents 6. So now we just obey order of operations, go from left to right. Although we could do these two first if we want, but we'll just keep it consistent. So anyway, 4 times 5 is 20 times a 6. What's 20 times 6? That would be 120, and there is your answer. And of course this one here, well, let's see, 2y over 4x. That really means 2 times y over 4 times x. Okay, well, 2 times y, that really means 2 times 6 over 4 times x, which was represented with 5. So, order of operations says I need to obey what's on top of the fraction bar first, and that would be, well, 2 times 6 is 12 over 4 times 5 is 20. You might say, oh, we're done, 12/20. But remember, we always have to simplify fractions. So if I divide both of these by 4, we'll try that, I will get 3/5. And you know what? Now we're done. 3/5. All right, so you're on a dodgeball league, and we'll say you're in leadership, and you have to make up teams so that this can happen to people. All right, so of course we would never want anybody to get hit in the face with a dodgeball. It's not even funny, kind of. Anyway, so you're in leadership, and you are in charge of making the teams, and you know that there are 245 players in the dodgeball league. I should say there are 245 players in your dodgeball league. Okay, not your dodgeball league. Anyway, so you're going to create a verbal model that helps us determine how many teams there's going to be. So how do we do that? Well, let's see. We know how many players there are in the league. League. Okay, that's 245. And we know that you're making teams of 7. So we're going to split this 245 up so that we have equal teams of 7. So we're going to take this players in the league, and we're going to divide that by the number of players per team. Okay. So what that ends up getting you, players in the league, well, that's 245. We're going to divide that by, well, making teams of 7. And if you take 245 divided by 7, you get 35. And what are we solving for here? Well, the number of teams. So 35 teams. So what we did was we used our verbal model to help us solve a real-world problem, which is kind of what we really want to do with math, because we want this to be relative and useful. And it is. So let's also take something like this and look at it. All right, so this is also really, really crucial when it comes to algebra. We need to be able to take a phrase and then create an expression from that. Okay, so it's kind of similar to what we did up there with the dodgeball. But anyway, the product of 43 and a number. Okay, so we need to be able to determine what that means. Well, first thing that sticks out to me is product. Okay, so it's going to be multiply. The product of something and something else, though. 43 is one of those things. And a number. The question is, what number? They don't tell us. So what does that mean if we don't know? Well, it means we use a variable, right? Okay, so 43 times x, and we could simplify that further just by writing 43x. We don't need the multiplication in between a number and a variable. When a number and a variable are next to each other like that, it means 43 times x. And that'd be your answer. So why don't you try these couple, and then we'll be done. All right, so I've given you 3. Go ahead, try that. Play the video when you're done. All right, so the sum of a number of -3 and a number. So sum is the first thing that stands out to me. Okay, so sum, of course, means addition. But what are we adding? Well, -3 and a number. -3 comes before the word and, so he goes on the left. And a number. What number? We don't know, so I use x. The quotient of 14 and a number. Well, quotient means, of course, division. So there's a couple ways I could write this. I could write it like this and say we're talking about division. Division of what? Well, 14 and a number. What number? We don't know. So I could do that. Or I could do 14 over x. That would also work. And then lastly, this one here, the difference. Okay, so we're obviously subtracting. The difference of what? Well, a number. So we don't know, so it's x and 17. So we're going to put the 17 there. So x minus 17. All right, so that is the end of the 1.1 video, guys. Thanks for sticking with it. Look forward to seeing you in class, talking more about this stuff. Toodles.